Welcome to today's New England Himss webinar, AI, ML, NLP. What does this alphabet soup mean to healthcare? Presented by Joe Grinstead, Vice President of Technology and Cloud at Healthcare Triangle. All lines have been muted upon entry today, so please send your questions via the Q&A feature and we will answer them at the end of today's session. With over 30 years of healthcare IT experience, Joe has a broad background, including working with healthcare organizations, as well as services and technology organizations. For the last several years, Joe has been focused on leveraging the public cloud in its various technologies, such as AI, ML, and NLP, to help healthcare organizations be more effective and efficient. Please join me in welcoming Joe today.
Elisa, thank you for that welcome. I appreciate it, and I thank you everybody for joining today. I hope this is an interesting session. As Elisa said, we're going to hold questions until the end, and part of that's because this presentation is sort of it builds on itself. So there's going to be a lot of, if we were to take questions as we go, a lot of the answers would be, well, I'm going to get to that in another slide or something. So we'll put the questions in at the end, but please, we do want the questions. We want to have a good dialogue. Really kind of hear your thoughts and questions as we go. So please put them in as we go, and then we'll get to them when we get to the end. We should have time for that. So who's this guy that's talking at you? I was looking at the names of the attendees, and there's more than a few out there that I recognize. So hello to those folks that I'm getting to talk to again, and hello to those that I'm meeting for the first time. As Elisa said, my name is Joe Grinstead. I'm with Healthcare Triangle. I'm the VP of Technology and Cloud. Been in health IT for a long time. Started off, 30 years ago as a computer operator in a hospital in Southern California. Live today in Dallas, Fort Worth. I am a geek. My wife will tell you there's more electronics and gadgets and other things in our house than we definitely need. And but that's what she gets for marrying me. I am a very proud husband and dad, and very excited to be able to talk with you guys today. I put my contact information on there. Please feel free to use that today, tomorrow, or at any time. Would love to hear from you, hear your thoughts, questions, ideas, and things as we embark on this journey to AI and ML and NLP. So every good presentation like this has to have the obligatory what you will learn slide. So we're going to cover that here. So first thing we're going to talk about is what are AI, ML, and NLP, and we're going to do those at a fairly foundational level. So if anybody on the call is, well versed in this, you may find some of this, probably redundant, and you may have some differing opinions from me, and I'll certainly acknowledge that, because these are still new enough technologies and areas of focus that there are differing opinions on them and differing opinions about what they mean and how they fit together. What I'm going to try to give you guys today is what I've learned. And like Elisa said, I've spent the last few years at Healthcare Triangle really, trying to understand these cloud technologies like the AI and everything, and how it can be useful to healthcare organizations. So what I'm going to share with you today is a lot of what I've learned as I've gone across that journey. I don't claim to know everything, but I wanted to share with you what I have and try to put it in the context of healthcare people like many of you who've been in the healthcare industry for a long time. As we go through, we're going to talk about where these technologies are being used, including by you, whether you know it or not. Actually, whether you know it or not, artificial intelligence is at work in this presentation right now. Zoom and most of the other carriers use artificial intelligence-based technology to manage noise canceling and cancel echoes out in the calls and things like that. We'll talk a little bit about some use cases in healthcare for AI, ML, and NLP. And then I want to touch on some ethical considerations, and we'll do that mostly through stories and talking about some of the things that have happened so far as collectively across all industries we've journeyed through the AI, ML, and NLP. If you want to take screenshots of the slides, please do so. I'll also say if you want to copy the whole slide deck, please email me. And then New England Himss is going to record this and post it for everybody. This might be a good slide to screenshot. These are 3 of the books that I've read as I've tried to, improve my understanding of these technologies, and they've been very, very helpful and very illustrative. The one on the left, the Real World AI, is just what it said. It is a very practical guide. I found it very helpful, very easy to read and understand. It's written by practitioners in this space that have real world examples, some of which we'll talk about as we go forward. But these are definitely some good resources to get into. So let's dive in. AI, artificial intelligence, machine learning, and natural language processing. These are all fields and focus areas of technology. Now, it's important to understand how they are organized, how they fit together. So AI is kind of an overarching term for all sorts of technologies and capabilities that include machine learning, and machine learning itself is a field of technologies and capabilities that include natural language processing. But in addition to machine learning, if you look at the field of artificial intelligence, you also see AI out there, deep neural networks, reasoning, problem solving, and a variety of other areas. Just as if you look within machine learning, in addition to natural language processing, there's image recognition, which can be used to view images and glean information out of that. There's sentiment analysis that really digs in and helps you understand what comments on a website or comments on a product site are telling you. So what is artificial intelligence? So artificial intelligence, and you guys will notice that I use Wikipedia a bit, may not be a source that my daughter can cite in her college courses, but there's no rule about that here, so I can cite it. And I do find Wikipedia helpful just because it cites so many other sources and you can kind of bring a lot of information together. But Wikipedia does a good job of defining artificial intelligence. It's very simply, it's intelligence demonstrated by machines. So let's think about that a little bit. What is intelligence? So intelligence, and again, Wikipedia helps us out here, can be described as the ability to perceive or infer information and retain it and apply it to the future. So this is the classic of how do you learn that the stove is hot? How does a kid learn that the stove is hot? Well, kids learn that the stove is hot because they reach up. Sometimes, despite how many times the parents tell them don't touch it, it's hot, they just have to touch the stove to learn that it's hot. Once they do that, they register information, and that information becomes intelligence, and it influences their future behaviors. Hopefully, it means they're not going to be trying to touch the stove again. So that's really what artificial intelligence is. It's learning through experience to affect what and how you're going to do things in the future. So where are some places we see artificial intelligence in everyday life today? Um, as many of you, I haven't stepped foot inside of a bank branch for a long, long time. And that's because of ATMs and online money and all that. But it's also because of the more recent technology of being able to deposit checks. Well, artificial intelligence enables all of that. If you've ever Google mapped or Apple mapped, there's artificial intelligence all over that, helping you to figure out the best route, calculating how long the route's going to take, factoring in information that it's gleaned from other map users about traffic jams and slow traffic and things like that. The autocomplete when you're on Google or Amazon or any of the other sites where when you start typing, it's not just a alphabetical autocomplete. It's looking at what's popular right now. It's also looking at what you've looked for before. So that's why you notice those autocompletes are actually fairly dynamic. So your autocomplete list looks different than my autocomplete list. Everybody's favorite Amazon Echo or Google Home or whichever smart speaker you might have in your home, Uber, the filters that help you clean out your email box from all the spam that we get are all artificial intelligence driven, as well as the autonomous driving vehicles that we're starting to see emerge. I have a vehicle that is smart enough to stay between the lanes, and the automated cruise control that could slow and speed up the vehicle based on the car in front of it and things. And that's all artificial intelligence at work in our everyday life. So now let's dive in a little bit to what machine learning is, if I can quit clicking the buttons. Machine learning, as I said, is a field of artificial intelligence, and its focus is on machines learning based on information that we as humans give to the machine. So it's developing computer algorithms based on data that it's been exposed to. And the simplest example, I think, or the most common example I hear is, how do you teach a computer to tell the difference between a dog and a cat in a picture? So at some point in the future, I want to be able to show pictures to the computer of a dog and have it know that it's a dog, or of a cat and have it know that it's a cat and have it know the difference. Well, the way we do that is we build up what we call annotated data. So we build up this training data of pictures of dogs and cats. And usually keep in mind, this is tens or hundreds of thousands of records. So this is not, this is not just 4 records. This is just, we're using this for illustration here. But we build up all of these pictures with the annotation that says, this is a dog, this is a cat, this is a dog, this is a cat. We then split that data into 2 sets of data. We split it into training data, and that training data is what we're actually going to use to feed to the model or to the machine learning to say, build a model out of this. So I'm going to give you a whole bunch of pictures and annotations, build a model. Once that model is built, we're going to use the other portion of the data to test the model. So we've used these pictures and tags up here to train the model, and then we're going to use these pictures and tags down here to see if our training worked. So to let you kind of see how that happens in a more stepwise, we start off again with that training data with annotation. We run it through a machine learning image. So all the dogs and cats and all the annotation. It comes out with a model. And what it's done is it's looked at all these pictures that we've tagged and said, well, in all the ones that are dogs, here are all of these characteristics that I've seen. And it could be anything. I mean, anything that it's using to understand it's building a model that says this is what a dog looks like, this is what a cat looks like. We then take that testing data, that data that we held back, and we now run that through that model to say, okay, how did that model do? And we get our results. And then we compare it with the annotation, and then the model gets tuned, and sometimes the model needs to be retrained. It's the training of the models in artificial intelligence and machine learning are the key components. And we'll talk a little bit in the ethical considerations about some places where machine learning and artificial intelligence can have some bias issues and other issues simply because of the data that was used to train it. So where are some places we're seeing machine learning being used every day? In healthcare today, we're seeing, I believe, Beth Israel Lahey Health there in the Boston area in New England has worked with Google on a dermatology machine learning study. And what this is a way for general practitioners and even patients to take pictures of skin conditions and send it in through the artificial intelligence machine learning model to say, is this something that merits a really rapid attention by a dermatologist, or is this just your everyday mole that is doesn't look like it has any malignant characteristics or anything? So we can get them into the dermatologist, but maybe we don't need to prioritize them as much. Reading images such as chest films and other things is another place where we're using machine learning. And essentially what we're doing is we take a stack of chest films that have already obviously been coded to say whether they're a positive, a negative, or malignant or benign, or whatever characteristic you want to track. And you can track multiple characteristics in your annotation. And we fed those through machine learning algorithms that built models that now allow us to look at, for example, a chest film and look for evidence of lung cancer, perhaps, or emphysema, or any of the other things you can glean from a chest film. Now, we're not at a place, and I don't think we'll be at a place for a little while, where we're going to be letting machine learning do the work of a radiologist in doing a diagnosis. But where we are today, and where I think we'll be for a while, is the ability to help prioritize. So if you think about a radiologist that's sitting there getting ready to read chest films, and they've got 150 of them, well, wouldn't it be nice if we could take that 150 and prioritize the ones where the machine learning algorithm thinks there's something suspicious there versus the ones where the algorithm says, looks like a normal chest film. That helps us get care to patients that need it more acutely faster. Again, not replacing the radiologist, although you'll hear talk of that. You'll hear talk of replacing radiologists and replacing lawyers and a bunch of others with the artificial intelligence technology. We're still a little bit away from that, but it definitely is one of the considerations we have to think about. If any of you've ever used a toll booth and just driven through without having to stop and pay tolls or anything, machine learning has been used to train the cameras to read the license plates automatically. So when you fly through that toll booth at full speed and then you get the bill in the mail or your credit card gets charged, that's because of machine learning. And then, of course, one of the most common ones, and sometimes one of the most controversial ones, is facial recognition. Facial recognition is great because it lets you open your phone with your face. And that's great. That's machine learning and artificial intelligence at work. It's less great when it becomes a controversial tool for society. So let's move into natural language processing. So again, machine learning is a subset of artificial intelligence, and NLP is a subset of machine learning. So natural language processing, and this I think is a very exciting technology for healthcare, simply because we tend to do a lot of stuff in healthcare today still in anecdotal notes rather than discrete data. We do more discrete data now than we did before meaningful use, but there's still a lot of data in healthcare that's tied up in progress notes, history and physicals, operative reports, consult reports, and things like that. And NLP is the technology that's going to help us unlock that. So NLP is a computer capable of understanding the contents of documents, including the contextual nuances. And that's a real key thing to understand. It can then extract information, categorize, and organize the documents. We've been doing some really interesting work here with some healthcare organizations to help them with their inbound faxing. You know, healthcare organizations are, I think, the only industry still propping up the fax machine business. And what happens is these organizations are receiving thousands of faxes in some cases every day. And we're able to help them using natural language processing to categorize what the document is as it comes in, extract information out of the document, including information like patient name and date of birth, and then match that patient to the electronic medical record. This takes a lot of human effort out of the process. It increases the accuracy, and it speeds up the processing of those documents, which in the end speeds up care for the patients. So this is, like I said, maybe you can tell, I get a little excited about it. Natural language processing is one of the places where we really see some value for healthcare. So I'm going to show you a video, and I'm not doing a live demo here because, you know, eccentricities of the internet and everything, and I didn't want to have to worry about something going wrong. But what I'm going to show you is a recording that I made yesterday on a service from Amazon Web Services, one of the big public cloud providers. This service is called Comprehend Medical. So AWS came out with a service called Comprehend, which was a generic NLP engine. And then they came out with a medical specific version of Comprehend called Comprehend Medical. And what you're going to see in this video is you're going to see a block of text. Then this is sample text that Amazon provides, but we could modify this. And actually, if you look at the web address down there in the lower left, you can go do this yourself. This is a block of text that is representative of a narrative report that you might see having been dictated by a physician or a caregiver about a patient. She's an 87-year-old woman. She's a high school teacher, et cetera, et cetera. What you're going to see is we're going to click Analyze, and then you're going to be able to see how Comprehend Medical is able to read this information, but it goes beyond just reading it word for word. It's able to contextualize it and build relationships. So for example, you'll see for the medication, for the Vyvanse, for the 50 milligrams daily at breakfast by mouth, you'll see it's able to break that out into discrete data elements. So let me just hit play here real quick. So here's our text, just kind of looking at everything that's there. We're going to click on Analyze. So now what it's done is it's really broken the data out. And I'm going to pause the video here because I want you to see the medications, because I think this is one of the most interesting ones. It's now parsed this data out to understand that we have a brand name of a drug, a dosage, a route or mode, and the frequency. And all of this is tied together contextually. That's important because now what that means is we can ultimately turn this into discrete data elements that can be used for data studies. It can be used for, as I said, like with the faxes, to match the document to the EHR. It can be used to populate data within the EHR with medication histories and things like that, all automatically. So on the back end, what you're seeing is what we call an API call, an application programming interface. So what we do is to work with Comprehend Medical on an automated basis. We send Comprehend Medical a data block like what you see here. The patient is an 87-year-old woman, what we saw on the original screen. And then it returns a JSON document, a JavaScript object notation document. And this document is a way to exchange data used by APIs across the internet. And what you can see is that it begins to break down the data that it saw into discrete data elements. So for example, a data type of age, 87, a data type of profession, high school teacher. All of that stuff is starting to be broken down in a way that we can now pull that out of there automatically and use it with technology to do a variety of things, whether it's automation, whether it's populating data in a database or any other thing. This is big. This is really big. The science behind this is pretty interesting. But at the end of the day, it's machine learning. It's feeding it lots and lots of documents from healthcare and training it. And then it gets better every day. That's one of the other great things about the services from like AWS and Google Cloud and Microsoft Azure. They're continually evolving these services to get better and better every day. So some places, other places where we see NLP today. We see it like we talked about in medical reports. We see it for the automated chatbots. If any of you, like I said, I buy a lot of gadgets and I buy a lot of them from Amazon, and every once in a while I got to reach out to Amazon customer service. And probably 90% of the time, I'm able to solve my problem without ever interacting with a human. I can interact, tell them, hey, I got the wrong thing, or it's the wrong size, or whatever, and it will automatically give me options to resolve the problem. So that's natural language processing and work as a chatbot. Sentiment analysis. So when you post comments on Amazon, when you post messages on Facebook and other social media, those companies are using sentiment analysis to glean information out of that. Is it a positive or a negative statement? Is it perhaps a violation of our terms of use? Does it contain profanity? Does it contain illegal content and things like that? And then obviously, again, one of everybody's favorites, your Amazon Echo. I got one sitting on the desk right next to me here. That is all natural language processing. That's hearing what you say. And when you talk to your Echo, it's not matching the sentence you gave it to pre-recorded sentences and making decisions. It's taking the pieces out of that sentence and using it to understand what you really mean in context. One of my fun examples is we keep our shopping list on our Echo, and I can tell it, Echo, add bread, milk, eggs, and bacon to the shopping list. And it's able to contextually understand that I don't mean add one line that says bread, milk, eggs, and bacon. It adds bread, it adds milk, it adds eggs, it adds bacon. That's all natural language processing at work in really understanding the information that you're giving to the NLP. Interesting statistic, and this is another reason why I think this is an exciting field. By 2025, Gartner's estimating that the demand for natural language processing is going to grow to $3.7 billion. So that tells you we're going to see a lot of movement in this space, which is more adoption, but it also means it's going to get better. It's going to get smarter. It's going to become more capable than it is today. So that's kind of an overview of AI, ML, and NLP, and gives you some sense of where we see them in use today. One of the things that I kind of really took away from the studying and the books that I've been reading and things is some of the things for How do you get started with this, with AI, ML, or NLP? I think I've got a business problem and I want to try to solve it with this. What are some things you need to do? Well, first and foremost, you need a clear and simple objective. Don't try to boil the ocean. Don't try to solve everything. Pick something that you can solve easily and you can discreetly identify that will allow you to show success with this that you can then build on. You need that annotated data to train the model, and that sometimes can be your biggest challenge. For example, you may have a stack of medical images somewhere, but they may not be coded or annotated. So you've got to code them so that you can train the model with the data from those images. You need massive computing power. Part of the reason why artificial intelligence is moving at the pace that it is in the last 5 to 10 years is because of the emergence of the cloud for computing. The cloud gives you access to that massive computing power that you need to do this. In a lot of cases, the most computing power is going to be spent building the model, that training process. And it's hard for individual organizations to rationalize putting that much computing power into their data center for what will be a temporary activity to train the data model. So the cloud gives you the ability to tap into those resources on demand and then shut them down when you don't need them anymore. You also need tools, and there's plenty of tools out in the public cloud that really help you with building machine learning models, training the model, improving the model, gives you access to other data sets that may help you improve your model, that really are at your fingertips out on the public cloud providers and out on the internet in general. Then you need to have expertise. This is still a very new field. There are a limited number of data scientists and data engineers out there that have the expertise to do this. That's where you need to tap into organizations that can help you get that expertise or build the expertise yourself. And I put this here to remind me to just re-emphasize clear and simple objective for your getting started on AI and NLP. And the reason I'm going back to this is because one of the things I read consistently as I went through looking at case studies for implementing these technologies is the ones that failed almost universally were because they were overscoped or abstractly scoped. They weren't clear and they weren't simple. They were trying to boil the ocean again, and they ran into problems because they were trying to do too much too fast. And in many cases, they didn't have the right data and all that stuff. But if they had chosen a more discrete activity, then that was something they could accomplish. One of the case studies was talking about a software company that wanted to improve their customer service using AI and ML. And they initially approached it as they were going to build this massive chatbot that could answer any question the customer would ask. And then they quickly realized that was too big of an ocean. So they focused on a discrete portion of that, which was password resets, which is a very discrete activity, and it's simple, but it's also high volume for them. So it met the low-hanging fruit criteria because it's high value, but it was something they could do simply and they could do quickly. They ultimately built from there, but they succeeded, and they felt like they succeeded because they started with something simple. All right, so we're going to pivot to talk a little bit about ethics. Ethics is it's an interesting space for the artificial intelligence field. The artificial intelligence is like any other tool. It's like any other technology leap forward. It's got huge potential to make a huge difference, to do lots of really, really good stuff. But just like social media, and a lot of other things, in the wrong hands or in inexperienced hands, it can be used inappropriately. The World Health Organization came out with a top 9 list of ethical issues in artificial intelligence. It starts with unemployment. There's an ethical consideration because artificial intelligence, while, as I've said before, I don't think we're at a place where AI is going to replace a radiologist. It may change a radiologist's job. And will it someday get to the point where it's smart enough to read chest films and be as accurate or more accurate and have a confidence level from society to do that job for a radiologist? It's absolutely possible. So what does that mean to that radiologist or that attorney who writes contracts that can now be written by artificial intelligence? That's something we have to think about. And we've had to think about that with every technological leap forward we've ever had as a society. Inequality, how do we make sure we distribute the wealth? How do we make sure that the wealth that artificial intelligence can help us generate is distributed appropriately? But also, how do we make sure that everybody has access to these capabilities so that it's not just the people with billions of dollars that can access this to generate more wealth? We want everybody to have access to these tools and capabilities. The humanity portion of it. How do machines affect our behavior and interaction? And we've seen versions of that already with social media and the way artificial intelligence almost can create an echo chamber for people because you only see things because of the algorithms. You only see things on social media that are sort of affirmative to what you've already looked at on social media. We have artificial stupidity, and we'll talk about some, examples of where this has happened. And this is not stupidity, and it's not intentional stupidity. It's mistakes that were made unintentionally. We've talked a little bit, and we'll talk a lot more about the idea of having a racist robot or an AI algorithm that is biased. Security has to continue to be a conversation. The evil genies, how do we keep from having players that shouldn't have access to this technology or who may misuse this technology to have access to it? Military drones are one of the places where people talk a lot about, this who should have access to these autonomous military drones that can, literally fly around the world and, deliver weapons and attack people and things like that. And, there's people who would say nobody should have them. There's people that should say only certain countries should have them. And it's sort of like the nuclear weapons argument, who should and shouldn't have, and all of that sort of stuff. But that's something we have to think about. We always hear, many of you've heard talk about the singularity. What happens when AI becomes self-aware and decides to start, taking on its own, managing its own fate in the world? And how do we make sure that, is there a point, I'm a Star Trek fan, probably no surprise to you, Data in the Star Trek The Next Generation, one of the topics they dealt with there was he a human, or was he equivalent to a human? Was he a life form? Was he a sentient being? Well, while we're not there yet, and it'll probably be a while, we're heading towards a place where there may be sentient awareness by these artificial intelligence capabilities. How do we deal with that? At what point is it not a computer and it's something that has awareness and deserves rights? Again, may not get there for a long time, but it needs to be on our radar screen, because I'd rather be thinking about it now and not need it than the other way around. One of the ways that the big players in the AI space are grappling with some of these ethical issues is they're coming up with AI principles. And these are Microsoft's, and all the other companies have them. They're similar. But essentially, what Microsoft has said is that as we move forward with artificial intelligence, there are some principles that we're going to follow to make sure that we're trying to stay between the lines from an ethical perspective. And it's, fairness, it's reliability, it's privacy, it's inclusiveness, it's transparency, and it's accountability. And I love the fact that they say people should be accountable for AI systems. This is, probably one of the largest technology companies in the world, and their focus is that people still have to control the technology. The technology should be there for the sake of the people. So, and as I said, AWS has this, Google has this, all of the big players in this space have it. But this is how they're trying to stay between the lines, and the lines get blurry. Sometimes the lines seem to disappear, and that's a continuing challenge. And if you're going to go into this field, how you manage and I'll say control, but how you make decisions ethically matters. So some of you may have heard of the Paperclip Maximizer theory or story. And what this is this is sort of an absurdist example of what could happen if artificial intelligence ran out of control. So we've got Dave here, and Dave owns a paperclip company, and Dave makes money when he sells paperclips, and he wants AI to figure out how to make the most paperclips possible. That's his statement. That's his goal. I want AI that can make the most paperclips possible, whatever it needs to do. So the AI responds, okay, Dave. The AI figures out how to optimize manufacturing. Great, we're making more paper clips in the same number of factories. That's a good thing. Optimizes the supply chain. How do I get more paper clips into the factory or more supplies into the factory to make more paper clips? Great, sounds good, right? Expand manufacturing, to take this very efficient manufacturing model and do it in more places. That sounds great. Oh, we're starting to run out of raw materials because we've made the manufacturing so good, we're going through our raw materials faster than we can produce them. So the AI has an answer. It says, well, let's begin to repurpose other metals. You know, people don't need those cars and the chairs they sit in and things like that, right? Because my goal is to make paper clips. That's my sole focus. Well, now we're beginning to run out of power because we've got such big manufacturing facilities, the utilities can't keep up. Well, that's fine. We'll divert power from other uses. Those hospitals don't need electricity, right? Because my goal is to make paper clips. Now we're running out of money because we're spending money to divert power and buy more supplies. Oh, that's easy. Artificial intelligence has been manipulating our financial markets for a long time. We're just going to manipulate it to benefit this paperclip manufacturing. Now the humans stand up and say, this is not what we wanted. Let's stop this. My goal is to make paper clips, so I will neutralize the human threat. Now, this is obviously, again, an absurdist example, but it's the value of an absurdist example is, as an intellectual exercise, you begin to think about where do we need to make sure as we go forward with artificial intelligence that we're putting rules up, that we're putting guardrails on the system, you know? So, you know, there's all sorts of things out there about, you know, the robot laws and things that I think it was Asimov that had, you know, the laws with robots or something, and robots can't harm humans and all that sort of stuff. But those are things we got to think about, because this artificial intelligence is really just a child, and you're just giving the child a task. And if you don't give it guardrails, the child will work to accomplish the task at any cost. For any of you who are more interested in this absurdist example, if you go out and Google Paperclip Maximizer, you'll find there's an online game you can play. And it's sort of interesting until it's not. But essentially what this game walks you through is the scenario I just talked through. Make the most paper clips, expand manufacturing, et cetera, et cetera, et cetera, and continue down the road of gaining whatever resources you need in order to be able to make the most paper clips. So some less funny issues with AI from an ethical perspective. I'm going to do this in 3 different stories, and these are all real stories. So many of you may carry an Apple credit card. I do, because they give me a discount on all the gadgets I buy from Apple. When Apple and Goldman Sachs first came out with this new Apple card, they were using an artificial intelligence algorithm to approve applicants and grant credit limits. Now, I believe this, they did not intentionally go in and add any bias to this intentionally, but the results of what was approved showed that female applicants were consistently given lower credit limits than male applicants. Interestingly, the response from Apple and Goldman Sachs at first is, yes, we know that's happening. We're not sure why. And that's a challenge with artificial intelligence, because these artificial intelligence models can become so deep and so complex that a human has a hard time understanding all of the nuances and rules in the algorithm. So they went back, they retrained their models, they eventually uncovered the problem and fixed it. But this was a case of an unintended consequence. There was no intent. I mean, their motivation is to generally give people as much of a credit limit as they can, because they want them to spend the money and pay the interest and all that sort of stuff. Another example of this, and this was talked about in one of those books, was IBM Watson. And we all know Watson from being on Jeopardy and beating Ken Jennings, and that was great and everything. But they were doing a project within the Watson group to roll out image recognition. So this was a technology that would be able to look at a picture and give you keywords out of that picture. So if it looked at a picture of a field with trees and wildflowers, it might come out and it might say field, it might say trees, it might say wildflowers, it might say sky, it might say sunny, all that sort of stuff. And they're doing this by using massive data sets to train this and annotating those data sets with these keywords to make the connection. A few days before they were getting ready to release the technology outside of the lab at IBM, one of the developers reached out to the product manager and said, we got to stop. This developer had fed Watson a picture of a person in a wheelchair, and one of the key words that Watson came back with was loser. So obviously, this is not consistent with who IBM is. It's not consistent with any of the people that were working on this project and what they wanted. But somehow in all of the annotated data, and remember, a lot of times when you're doing annotated data, you're bringing data from different sources together to try to train with. So you might be taking other people's data sets and using those to train your model. And it's really important to understand the data provenance. Where did the data come from and what the content of the data is? But understand, these folks were processing hundreds and hundreds of thousands of records and images with hundreds and hundreds of thousands of word tags on them. It's impossible for humans to look at every one, but enough had slipped through that Watson now thought that a person in a wheelchair was a loser. Obviously, they stopped the project, they fixed it, they didn't do the public release, they addressed it, but this is another case of unintended consequences. The last one was fairly public. ProPublica actually exposed this one. The state of Florida was using a system called Compass to measure and predict recidivism in inmates in jail. So recidivism is what's the likelihood that this person is going to come back to jail after they leave jail. And so they fed it all this data, and essentially what they found out as they looked at the results, down the road, was that it had a racial bias, and it tended to identify people of color, with all other factors being equal to someone who's Caucasian. People of color had a higher recidivism likelihood. Again, nobody thinks this is intentional, but this is a case of not managing your training data, not understanding your training data, and not testing it and validating it. These are ethics at work, folks. So part of what we have to be doing as we go forward with artificial intelligence is applying the ethical questions. Is this fair? Is it equitable? Is it balanced? Does it meet our ethics? Does it meet our norms? Does it meet our standards for what's right? IBM would never call somebody in a wheelchair a loser. That's just not who they are. That's not who any public company is, because you wouldn't survive the publicity mess. But that was the consequence of the training data and how it was processed. So wrapping up in the ethics space, let's talk a little bit about security. So security in AI is kind of an interesting topic. Because first and foremost, we've got to continue to do all the stuff we currently do around IT security. We've got to have multi-factor authentication. We've got to train our users what a phishing email looks like. We've got to train our users about how to properly access information and all that sort of stuff. But we then have to also, as I talked about, increase our focus on data ownership, especially around source data. Where did this data come from? What's the provenance of it? What's the quality of it? What's the reliability of it? What data, then when the AI produces data, what can be done with that data? Where can that data be shared? Is there de-identification necessary? Once we're up on the cloud, we have to start thinking about data residency. Where is data? So, if you're in the United States and you have healthcare data should stay in the United States. So if you're using Amazon, Google, or Microsoft to store that data, you better make sure it's in one of their regions that is in the United States. Same if you're doing it for Canadian patient data, you got to do it in a Canadian region of those. And that applies around the world. There are data residency requirements legally and ethically that we have to meet. And then obviously encryption of data, making sure data is being encrypted properly so that it can be protected and things like that. So, security is a big deal, but security is also kind of continuing to do a lot of the same stuff that we pay attention to around IT security already today. All right, last slide before the Q&A session, and I see we've got some questions. That's great. Would love to have some more, so please feel free to open up that Q&A box on the Zoom meeting and add your question or comment if you have thoughts or comments. Let's get those out there and have a conversation. So let's talk a little bit about some applications in healthcare that we're already seeing start to emerge. And some of these we've touched on as we've gone through the slide. Machine learning to analyze and prioritize medical images, whether it's an X-ray or EKGs, things like that. AI and ML to predict patient behaviors. So we're starting to see models emerge to predict which patients potentially are going to be less likely to follow their prescribed medication routine. This can factor into a readmission risk. Which patients are more likely to not show up for their appointments? So this can factor into how we manage those patients, how many times we send them alerts to remind them of their appointments, and how aggressively we confirm their appointments. AI and ML to monitor patients remotely. We did some really interesting work as Healthcare Triangle with a company that helps keep seniors in their home longer and safely. And they do this with a bunch of devices in the home, smart devices, wearables, and things like that, that allow you to keep an eye on the patient fairly unobtrusively. But they can do things like monitor activity levels, did they get out of bed and things. And the AI and ML have helped us to spot the anomalies. So if my grandmother always gets out of bed by 7:30 in the morning every morning, and we've not seen any activity in the house by 7:45 or 8 o'clock, that's an anomaly that someone needs to follow up on. But if grandma got up and did her normal stuff and all that, and grandma doesn't need nobody bothering her, grandma's good. And we can monitor things like taking medications, we can do blood pressure cuffs and a variety of things. But this allows these seniors to remain more independent in their homes, and it gives their family peace of mind that they're okay. Natural language processing to liberate data from documents. This, again, I think this is pretty important stuff for healthcare. Whether it's a fax or it's a dictated note by a doctor, a scanned document that a patient carried in with them or something, that NLP can really help us get that data out of those documents quickly, categorize the documents, and route the documents around. Chatbots. I think natural language processing chatbots for basic patient communications. If you go talk to the front desk at a typical healthcare organization or to the scheduling office at a typical healthcare organization, a large percentage of their calls are cancellations and reschedules. Well, what if we could just very, very focused say, let's build a chat bot that can let people cancel their appointment and reschedule that appointment automatically. We're not going to boil the ocean. We're not going to do everything that scheduling center does, but let's at least do those things. They're high volume, they're simple, we can probably do it. And then we let the staff at that scheduling center focus on the higher value activities of trying to get the patient coordinated across multiple disciplines so they can only have to make one visit to the medical center, or trying to help a patient who has an acute need get into a high demand service that may not have capacity and things like that. Use these chatbots to handle the more mundane stuff so that we free them up to practice at the top of their license. And then the last one that I'm starting to really see some interesting play in is predictive analytics to forecast volumes for healthcare. So, and certainly the past 18 months, a lot of the rules that we use to forecast, volumes in an ER and things like that, some of the rules have just gone out the window. But healthcare still has a need to be able to predict, is this weekend going to be extra busy in my ER? And up until now, most of what organizations have had to look at is they look back last week, last month, last year, and see what it looked like, and check what's going on in the community. Are we having a big concert or rally or something like that? And use those sorts of factors to try to predict it. Well, artificial intelligence can do that, and it can even expand beyond it. We can feed weather data to the artificial intelligence. We can feed social media data and tags for their geography into the artificial intelligence model, and it can begin to see patterns and things that we don't understand. I was talking to my mother-in-law about this. My mother-in-law used to be admissions and business office director for a hospital system. And one of the things she always did was, when she was building up the schedule for her registration clerks in the ER for the weekend, she flipped her calendar and looked at the phases of the moon. And she said, Joe, I don't know why, but for some reason, when the moon was full, more people came into the ER. And I'm betting there's some clinical people on here whose heads are nodding. So we staffed up. Now, was it really the phases of the moon? Maybe, maybe not. Was that causation or was that just correlation? I don't know, could be. But AI can maybe help us begin to break down what's really going on there, or maybe it is the phases of the moon. Okay, so that's fine. We don't know why, but we know it is. So, that predictive analytics to do things like that, I think, is a real big opportunity for healthcare to start really taking advantage of some of these technologies today. And if you guys are seeing examples or have examples, I'd certainly love to hear them. So I'm going to catch my breath here for just a second. I think Mike and Elisa, we have some questions in the Q&A, so we can definitely jump into those if you guys want to. My contact information is there. When you exit this meeting, you are going to get the opportunity to fill out a survey. We'd love your feedback on it. I would personally love your feedback on it. And I'd also really appreciate if you just email me with your feedback or any questions or thoughts. We want this to be valuable to you, to the industry. And also, if you'd like a copy of the slides, please feel free to email me, and I'd be happy to send you a PDF of the deck that I used today. So with that, Mike or Lisa, where are we with questions?
So the first question is from John, and he says, Joe, it's a long one, Joe, so hold on. Joe, it took Google a number of years to teach the machine learning algorithm to recognize a cat with 80% efficiency. A human baby of 2 years old can distinguish a cat instinctively. Peter Thiel made a joke about this in his 0 to 1 book. How good and how efficient is the current state of art in machine learning? I haven't seen any major breakthroughs in new and innovative algorithms in neural net to enhance the efficiency of machine learning in the past 20 years. We are only good in expanding the number of GPUs, 3,000 plus, to enhance training. That is not good. So I guess the question is, how good and how efficient is the current state?
Yeah, and that's a great question and comment, Don. And I generally agree with you. And by the way, the 0 to 1 book is another great book that I would recommend. I would say it's been a problem as we've grown artificial intelligence to it's been a hardware problem in a lot of cases. As you said, we're just throwing more hardware at it, more GPUs, more processors, and there's a limit to how much we can scale that even in the cloud. I will say, because I talk to the people that are doing this sort of stuff at Amazon and Google. I haven't talked as much with Microsoft, but I've talked a lot with Amazon and Google. They are laser focused on improving the algorithm that builds the algorithms. They are doing that on a day-to-day basis. Their progress is incremental. And your point about how long it took to train a computer to recognize a cat versus a 2-year-old can do it is correct. But what I would say is that if we were doing that today, we would build that recognition faster than we did before. Now, some of that's just because we're throwing more hardware at it again. But I do think there is also continual improvement in the algorithm, and there is some exciting stuff happening there.
So the next question is from Jen. She's asking, how are we able to ensure that NLP or ML are accurate in terms of what they are taught and what they produce? Are qualified humans reviewing a sample of the data and then assuming the rest of the data set is correct?
It's some of that. So, for example, the organization we're working with to improve the processing of the faxes with NLP, at the outset of the project, they did 100% review of everything that the algorithm produced, and we had really good results. We were very happy with them. The other thing that happens when you're using artificial intelligence is that it tends to produce a confidence percentage as it's doing things. So its algorithm is designed to give you not only this is what I think it is, but this is how confident I am in my answer. And that can help also guide whether or not you trust the data. So we have cases where the documents being categorized only have a 60% confidence from the algorithm as that this. So if it says it's a lab result, but I'm only 60% sure, we move that over to human intervention. So there's a whole concept in this field of human in the loop, where you take the data that the algorithm is not confident in and move it in front of a human to process it. Ideally, what you do is you capture what that human does and you use it to improve the algorithm for the future. I will say we're a long way away, if we ever could get there, to 100% on AI and ML and that sort of stuff. There's always going to be a percentage, but the goal again is to get it to where it's high enough confidence level that you can use your human resources to practice the more high value activities. And then it does come down to training too. And that's why when I talked about the training data that we used, you hold out a portion of the data and feed it into the algorithm after it's developed it with the training data and see how well it does with this new testing data. So, essentially I've given it 100,000 records of dogs and cats, but I've got another 25,000 over here. Once I'm done training it, I push those 25,000 through and see what it comes out with and use that to sort of validate the reliability. But there is always a large focus among data scientists and those sorts of folks in the reliability of these models.
So the next question is from John again. He asked, Joe, can you talk about the role of AI in solving the interoperability problem, WRT data sharing? I'm interested in Himss semantic interoperability. That is the interoperability this question is asking about.
So I'm going to confess to not being as deeply versed in that. So what I'm going to say is we are starting to see conversations around using AI and ML to more intelligently route data based on the characteristics of the data. So, jumping into the integration stream between healthcare organizations and figuring out how that data should be routed more dynamically than our sort of static point-to-point HL7 interfaces today. The AI and ML, as we start to train it on certain characteristics to watch for, an example might be a really abnormal lab result that has a certain value that may indicate a communicable disease outbreak or something. Maybe that we use AI to automatically trigger messaging into a public health organization about that or something. So that's some of the stuff I've seen. I apologize if I'm not completely answering your question. I'd love to get into more of an email conversation with you. I've got a guy that works with me at Healthcare Triangle who lives and breathes all of this Himss interoperability stages and the semantic interoperability, and I know he'd love to chat. So please feel free to drop me an email, and I'd love to continue the conversation.
The next question is from Jen again. She says, when thinking about AI, I noticed that there is attention paid to wanting transparency around algorithms and data. Is this something that you think the field will be open to, or will the work be done behind the scenes to build out algorithms continue to be kept confidential?
It's a tricky question, right? I think, there's a couple factors to think about there. One, some of these algorithms will quickly become intellectual property for the people that develop them. So like any intellectual property, there's going to be a desire to protect it, which, okay, that's fine. But then I think what we will see, and we're starting to see emerging, is organizations that can audit and provide independent opinion on the equitability and the reliability of the AI model. So it doesn't necessarily mean we're going to expose it to everybody, but these organizations can come in and give a report that can be trusted to say that the model is fair and equitable and reliable. So that's one part. And we kind of see that happening with the cloud providers like Amazon about their data centers. They don't let people tour their data centers. They don't let people into their data centers. That's a whole security conversation. I get it. That makes sense. But what they have done is they've contracted with external third-party organizations to do audits of their data center and will attest to the capabilities and things of that data center. I think we're going to see similar things happening with these AI models. The other part of the AI model that's hard sometimes is it's becoming more difficult for humans to truly understand. So in the case of the Goldman Sachs Apple Card, it's becoming more difficult for humans to really understand what these models are truly doing and all of the relationships that they're making and connecting to figure out how to process these things. There's just so many connections and so many nuances and branches to them. It's becoming harder and harder for the human to absorb it. What I think you'll start to see there, and we already are a little bit, is we're going to have AI to audit AI. So we're going to start to have tools in AI that can help audit the AI itself. And I think that'll start to help us there.
So
got time for one more?
Yes, that's what I was thinking. One more question. And then I will have a report that I can give you, Joe, with all these questions so you can respond to them as well.
Awesome.
So Alan asks, how receptive are you finding health systems to having their data being interpreted by a cloud service?
I would say that there's been a strong pivot there over the last few years. When I first started down this path with Healthcare Triangle and looking at public cloud and how it could be used to process healthcare data, I was fairly skeptical myself, to be honest. I've been in this business for 30 years, and we've all had the HIPAA and PHI and security, really beat into us, and none of us want to be on the front page of any newspapers for the wrong reason. But I became more confident because I saw A, what the cloud providers were doing, and B, that there are companies like us at Healthcare Triangle who can help organizations and have deep experience with highly regulated workloads like PHI on the public cloud to make sure that it is secure. What I would say is it is absolutely possible to achieve the security in the public cloud for your data that you have with it on-prem. And in fact, in some cases, you can exceed that security. But that is only a possibility, and the only way that possibility gets realized is by understanding it and knowing how to do it. So, that's where, if you look at any of the cloud providers, Amazon, Microsoft, or Google, they all have what they call a shared responsibility model for security. And there's things that they own, and there's things that you as the customer and or your managed services provider like Healthcare Triangle need to own. If you're following that model and you're owning that sort of stuff, and you're applying the standards that we apply to all of our healthcare workloads, then you have every reason to be confident. And I'm definitely seeing more openness to that conversation as healthcare leaders are becoming more educated about it. And if you're skeptical about it, you're right to be skeptical. But my suggestion would be get educated so that you understand it a little bit more.
Well, we do have a number of more questions in the Q&A, and like I said, I will make sure I get those questions to Joe so he can get answers back to those respective attendees today. And I want to thank Joe for taking the time to present to New England Himss today. And thank you also to our premier sponsor, Healthcare Triangle, for coordinating this with Joe. The CP Himss credit, the presentation handouts, and the recording link will be sent to everyone via email later this week. So you don't have to reach out to Joe to get the handouts. We will be sending those to you. No worries. No problem. And the recording then will also be posted on the New England Himss YouTube channel for your easy access as well. Our next session is on September 23rd, Emerging Healthcare Leaders, Stories of Student Engagement and Success. So if anyone's interested in joining that, the registration is on our New England Himss website. So thank you again, Joe, for joining us, and everybody have a great week. Thanks so much.
Thank you.